So now that we know the Baeyer-Villiger reaction, it'd be useful to go over a few examples and to recognize this rule I've written out at the top. So in the mechanism video I made, I didn't talk about what happens if you have some sort of ketone that is asymmetrical, and this rule addresses that. So um, let's go ahead and do a few examples. And abiding by this rule, saying that methyl will shift unless there's a primary alkyl group, and then a primary alkyl group won't shift if there's a secondary, and so on, and you can get the idea. So if we are given, for example, if we are given um, something like this, and we're combining it with, again, we'll use MCPBA. And then just dichloromethane is fine as our solvent. And we're expected to find what our answer will be. So abiding by that rule on the top, I'll let you guys have a minute to go ahead and figure this one out. So if you tried it, looking at this rule at the top, we, well, I guess actually let's first look at what we're dealing with. We're dealing with what looks like an aryl group and then some sort of a primary carbon group. And so we see up here in our rule, there's our primary group, and then and it is pretty low on the rule chart I've written up here. Um, and then going forward down, we see an aryl group has a higher priority to migrate than a primary alkyl group will. So we can expect that our answer will be our answer will look like this. And so all I've done is I've noticed that I have an aryl group that has priority over a primary alkyl group, and so that's where the migration is going to occur. And so it also is useful to remember the mechanism so that you know what I mean when I say migration, because in the actual mechanism, this aryl group actually does break and move around. So let's go ahead and do a second example. Okay, so we're given this thing on the left, and we're asked, again, just being simple, we're asked what will the product be. So again, looking at those rules on the top, I would identify what we have in our reactants and then kind of compare that to our rule that we have in our head. And so I'm looking and I see there's an aryl group right here on the left, and then over on the right side we have a benzyl group. And so benzyl group, I'm going to look at that as being a primary alkyl group because this carbon right here is attached to only one other carbon, which is right there. And so it's again a primary versus an aryl. And so the same decision on our rule would apply here. So let's draw our product. So it's mostly similar for the most part. So on this next one, let me draw it out. Let's put it right there. So on this next one, I'm going to use a different peroxy acid. Oops. Yeah, it's fine. So this is trifluoperacetic acid. Again, you can use any solvent. I'm going to use dichloromethane. And so again, abiding by those rules at the top, what can we expect to happen as our major product? Well, I'm going to redraw everything real quick. Actually, no, I'm not, because that makes it a lot harder to talk about. Okay, so going backstepping, um, looking at what we have again, this is a primary carbon or a primary alkyl group, and then this one right here is a tertiary alkyl group. And so we expect the migration to occur with this tertiary alkyl group. So if we added an oxygen to this ring, which is what needs to happen if it is truly a Baeyer-Villiger, then we'll end up having, instead of a 5-member ring, a 6-member ring. And so our answer would look like this. Just like that. Okay, let's go ahead and try this one. What if we had a group that looked like this? And we're using that trifluoroper acetic acid on it. So that's this. What do we expect to happen? Well, noticing what we have on the left, we have some methyl group that is well, some methyl group on the left. So this is our methyl group, and then over on the right we have a secondary alkyl group. And so we know that secondary alkyl groups beat our methyl groups, and so we expect the migration to occur like this. Okay, let's do another one. So here we're asked the same question, what do we expect the major product to be? Well, if you're given something like this, it would not be totally far-fetched if you suggested that there'd be a 50-50 mixture of both products. And why is that? Well, if we look over here at a rule, we see that our secondary alkyl group is about equal to the migratory the migratory aptitude to an aryl group. And so what that means is that we would expect about a 50-50 split of the secondary group being the migrating group and the aryl group being the other 50%. And so I will write both of them right here. Perfect. And let's do one more. Just make the element neater. And so now what about this one? What do we expect the answer to be? Well, again, looking over at our rules, we see that we're dealing with some sort of a secondary group, and then a tertiary group. And we know that tertiary groups beat out the secondary group, and so we should expect our tertiary group to be the group that migrates. And that would be our answer.